Good afternoon. This is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, this is our last lectures for this particular course, econometric modeling. So, today we will just summarize what we have discussed in our couple of lectures. This is the summarize fact, what is all about econometric modeling, how we have started and how we have to come to an end. So, that is our agenda. So, today's discussions. Very specifically, we start with basics of econometric modeling. So, we defined what is all about econometrics and how it is fitted with modeling concepts. Then we have means what is econometrics, why you know econometrics and how we have to integrate with modeling. Then in the same times we have discussed various features, various applications and various structures and also related areas like biometrics, technometrics, sociometrics, anthropometrics, cliometrics, geometrics, etc. So, these are all related areas we have. Econometric has an application. So, that means we can make a guess what is the importance or how it is important so far as a feature is concerned, means that is with respect to econometric modeling. So, econometric modeling is fundamentally is its roots from math start and economics, and it has spreaded over many areas. As a result, there are many applications. Nowadays, without econometrics, it is very difficult to handle so many problems. So, what I will do right now, I will just briefing the concepts what we have discussed in the last lectures. So, we started with various definition about econometric modeling, that too thereafter we have discussed basics of econometric modeling, that to univariate statistic, bivariate statistic, multivariate statistics and also its related concept like hypothesis testing, probability, etc. So, then we have categorically divided into various structures through which we get to know the concepts of econometric modeling and what we can call integration with the business forecasting. So, today what I will do, I will just give you briefing about this particular structures. So, what we can do here is because in the beginning I started with the modeling strategy. So, now we are in the end. So, we have to summarize how the modeling strategy begins and how it comes to an end. In fact, it has many areas, many applications, many branches. So, it is not straightforward. So, we have to start here and we have to end here. If it is a particular technique, then you can know what is the starting point and what is the ending point. But here the thing is that we have in between we have discussed so many means techniques, so many issues, so many problems, so many strategies. So, it is very difficult to put it in a summary form. So, because every application has a different issues, different application and different strategy. So, we will give you general framework here where, so how we have to start the econometric modeling. So, what are the procedural measures? So, how we have to begin, so then how we have to analyze and how we have to end. So, that is, so we will be briefing this particular strategic issues, then we will come to the summary part. Okay. So, we started with the means the modeling strategy completely for econometric modeling begins with the problem statement. Okay. So, we start with the problem statement, because without having complete problems, clear cut issues, then econometric modeling cannot be applied properly. So, without any theory, without any serious problems, it is very difficult to say which particular econometric technique you have to apply to analyze that particular issue. So, problem statement is very important, that is the beginning of this econometric modeling. So, with the problem statement, so we have to come out with the objective specifications. Okay. objective specifications. We have to come out with objective specification, then followed by hypothesis testings. Okay, hypothesis testings. Okay, so that means once you know the problem statement, so with respect to particular problem, so we have to form objectives, and corresponding to that objective we have to set the hypothesis. The agenda of hypothesis is just to investigate. Okay, so hypothesis means it is a statement which is not verified, which we like to verify. It is usually handled through the integration of null hypothesis and alternative hypothesis. So, which we have discussed long back. Okay. So, the first step is a problem statement, then second step is objective specification, third step is a hypothesis, not hypothesis testing, it is a hypothesis specification. Okay. So, we will go testing later part, hypothesis specification. Okay. So, far as testing is concerned, so we have to apply the null hypothesis fonda and alternative hypothesis fonda. So, then after getting a hypothesis specification, then we will go for formulation of mathematical form of the model. Okay. Mathematical form of the model. Okay. So, this is we have to formulate the mathematical form of the model. Then so we have to move to statistical form of the models. Okay. Statistical form of the model. Then it has to be followed by data collections, because you see here data collection, or you can say informations. You see, so once you have a problem, you have to specify a particular objective or many particular objectives. So, it may be single, it may be multiple objectives. So, corresponding objective you have to formulate the hypothesis. Now, once you have a hypothesis in front of you, so according to the problem specification and hypothesis setup, so you have to formulate a models, that is mathematical form of the model. So, now that mathematical form of the models, it has to be transferred into statistical form of the model, because we need to verify whether that model is perfectly okay or not. So, now because we have to apply strategy with respect to that model. So, statistic has to investigate whether that particular models which we have designed for that particular specific specification of problem. So, whether it is fruitful or not. So, we have to verify that one first in statistically, then we have to apply it in a real life situation. So, now once you have statistical form of the model, so then what you have to do, you have to go for estimations. Okay. Before estimation, so you need informations, and that is nothing but you need data. So, data collection and information must be there. So, then we have to go for model estimations. Okay. So, we have to go for model estimations. Okay. We have to go for model estimation, then we have to turn into model reliability. Okay. Model reliability. So, we have to we start with the problem statement, objective specification, hypothesis specification, mathematical form of the model, statistical form of the model, data collection, then model estimation, then model reliability. So, now what is all about this model reliability? Let me here explain. So, now model reliability. So, model reliability has a three parts. One is called as a goodness fit test GFT, then specification test ST, then out of sample prediction test OSPT. Okay, sample prediction test. So, GFT it will give you overall fitness of the model. So, this is with respect to parameter weightage, then this is with respect to residual aspects. Okay, so that means it is mostly on DG test. So, now so far as reliability is concerned, so we have three different tests. So, goodness fit test, specification test, out of sample prediction test. So, obviously, this test will clarify you whether this model is okay, reliable one or not. So, that means every case there is a yes no situation. Okay, yes no situations. So, every times there is a yes no situation. Let us assume that every case there is a you can say yes yes yes. Okay. So, now if it is say yes yes yes. Okay, if it is yes yes yes, so then you have to go to next part of the models, it is called as a analysis. Okay, so we have to analyze this analysis, or we have to interpret the models. Okay, interpretation of the models. So, now with respect to interpretation, we have to go for hypothesis testings. Okay, hypothesis hypothesis testing. Okay, hypothesis testing. Then you can say forecasting. So, once hypothesis is clear, here we have to apply null hypothesis and alternative hypothesis. Our aim is to reject the null hypothesis, which is assumed to be a correct statements, but we have to reject this statement. So, that we have to prove the fact. Okay. So, hypothesis testing, then it has to be forecasting or predictions, then you have to finally you have to use for policy use. Okay. So, these are the steps which we have to insert in the case of, means these are all modeling strategies. So, that means what is our structure here. So, if you call it is step 1, then this is step 2, this is step 3, this is step 4. Okay. So, this is step 5, okay, this is step 6, this is step 7, okay, this is step 8. Okay. So, then followed by this is step 9. Okay, step 9. So, now in the step 9, so what we have done? So, we have gone through 3 different tests. So, if all these tests are clarify that if the model is reliable, then we have to go for step number 10, okay, followed by step 11, followed by step 12, then followed by step 13. Okay. So, these are the number of steps which we have inserted. Okay. So, these are the following strategy, you can say following steps which we have to follow in the case of modeling strategy. But if it is in case no, then obviously we have to go back to again step 4. Okay. So, if it is no, then we have to go back to step 4. Then again you have to redesign the mathematical form of the model. So, you have to redesign the statistical form of the model, then you use same data structures, then you have to go for model estimation, then you have to go for model reliability, then again you have to come to model reliability, you have to go for specification test, goodness fit test, and out of sample prediction test. Then if all these will be clear, then obviously you will go for interpretation analysis, then followed by hypothesis testing, then you have to use for prediction and forecasting, then finally that model is useful for available for policy use. But if it is again no, then again you still go to step 4. So, again you have to redesign the models till you get the best models through which you can predict the fact, or you can say predict your structures. Then you have to analyze this you have to use for policy, you have to apply this model for policy use. So, that is the modeling strategy which we have started in the early phase of our lectures. So, with keeping in mind all these strategic rules, so we have to enter each and every problem, then accordingly we have to come to a conclusions. Okay. So, in between the interpretation analysis are very complicated and very interesting, sometimes it is very strategic. So, what we have already discussed all these details. So, I am not going to discuss each and every component right now. So, what I will do now, so I will just briefly highlight what are the techniques we have discussed, and we will highlight little bit what is that means what is all about the techniques, then finally we will give the conclusions. Okay. So, the modeling started with, we start with the regression analysis particularly. So, bivariate modeling, then trivariate modeling, then multivariate modeling. So, multivariate modeling. So, we started with the regression analysis, that is the entry. Beforehand what we have discussed regarding probability hypothesis, then introductions, then related things what we have discussed, these are all basics of this papers. But basically the real effect is starting from the regression modeling, that to bivariate modeling, trivariate modeling and multivariate modeling. So, we have gone through details estimation process, because the basic fact is that, so the moment you will transfer mathematical form of the model to statistical form of the model, then ultimately we need to estimate the parameters, and where we have to minimize the error terms. Every time where here a standard fact is that, so the structure is one dependent variables and several one or several independent variables and something error terms which not captured in your models, that will take care of. Okay. So, so there are 3 parts altogether. So, dependent structures, independent structures, then error structures. So, the way we will minimize the structures, minimize the error term, then we will get alpha estimated parameters. Then through the estimated parameters, so we have to go for all these reliability tests, that is goodness fit test, specification test, out of sample prediction test. Basically what we have done, so we have gone through the parameter statistics, that is suppose this model will be like this, y equal to say alpha plus summation beta 1 x 1s plus beta 2 x 2, okay, beta 3 x 3, okay, something like this way, okay, beta for x 4. So then what is that? This is complete model. So then we ultimately we get y heads, so that is alpha heads, beta heads, beta 1 head, beta 2 head, beta 3 head, then beta 4 head. So these are the things we need to calculate, okay. So then it has to be significant, all these things, then followed by the overall fitness of the model has to be you can say considerably very high, that is R square, adjusted R square, and also means more or less that is ANOVA tables, analysis of variance. So we always keep touch with the R square, adjusted R square, residual sum square, explain sum squares, then F statistics, and accordingly its significance level. So this is how we have we have to conclude this particular component, okay. So then after discussing all these things with respect to bivariate modeling, trivariate modeling, multivariate modeling. In fact, in the multivariate modeling we have discussed generalized approach and also matrix approach. So more or less the fact is that, so ultimately we need to estimate the parameters, then we have to check the significance of the parameters, and finally we have to check the overall fitness of the models, and finally we have to go through all these diagnostic tests, okay. So these are the facts we have to study under all these conditions. Then finally we have discussed various aspects of econometric modeling, okay. So that too we have discussed multicollinearity issue, autocorrelation issue, heteroscedasticity issue, and so other diagnostic tests. So multicollinearity issue is basically give you the signal of the means when we fit a model. So generally we start with the OLS technique to minimize the error sum squares. So here we have standard assumptions. The standard assumption ultimately turn into all these aspects of regression modeling. So multicollinearity one problem where we like to know what is the existence of linear relationship among the regressors, that is independent variable. If all these regressors are independent, then obviously model is completely fit and we can consider as a best fitted models. Otherwise it is we have to go round after round till we get the best fitted models. This is all about the multicollinearity issue, okay. Then autocorrelation issue. So it is a problem regarding the error terms. So means when we fit error terms, when we will get error terms y u hat, then obviously we will get ut, ut minus 1, ut minus 2, etc. Okay. So we like to know, like like the relationship between or among regressors. So we may have relationship among the error terms ut, ut minus 1, ut minus 2 like this, or u1, u2, u3, etc. So these terms should be also independent, okay. So but the reality is that they cannot be independent. So there is a little bit they may have interdependence. So we like to see, means our standard assumption that the correlation or covariance between ut error terms should be equal to 0. If it is not 0, then there is autocorrelation problem. So if there is autocorrelation problem, means existence of autocorrelation, then we have to see the range. With this range we have to see whether we can proceed for prediction and forecasting, or we have to redesign this model. So this is the effect of autocorrelation. Then finally heteroscedasticity. Heteroscedasticity is also problem of error terms. It is related to problem related to error terms. So in the case of autocorrelation we take care the covariance issue, but in the case of heteroscedasticity we take care the variance issue. So that means our standard assumption is that error variance should be equal or constant for each and every unit. But if error variance are not constant, then obviously what you have to do, we have to redesign again models till you get the structures where the error variance will be somewhat okay or constant. So then that model can be considered as the best fitted model. So autocorrelation is a covariance of error terms. This is variance, heteroscedasticity is the variance of error term. Then in the meantime we have discussed so many other issues, diagnostic tests. So like goodness of fit models, and also specification of the model, like the use of AIC statistics, AKI information criteria, final prediction criteria, etc. These are the facts, these are the components through which we have to come to a conclusion whether this model is can be considered as the best models or not. So, these are the facts we have discussed in this entire structures. Then we have also discussed very hardcore problems. Beside these problems, we have discussed severe problems like dummy variable modeling. So, dummy variable modeling. So, in the case of dummy variable modeling, so we have discussed under two heads, dummy dependent and dummy independent. Okay. So, under dummy dependent, we have discussed linear probability models, then logit models, then probit models. So, these are very interesting component. Probit models. Dummy variable means this before dummy variable, whatever concept we usually discuss, these are one standard assumption is that all these variables are in a quantitative format and readily available. So, we have to just apply the technique and you have to get through the results, and after that you have to go for all reliability testing, etc. But some of the problems you will find the variables are categorical, binary in nature. So, in that case it is not available in direct in quantitative form. So, we have to apply the dummy variable technique. So, once this type of problem is there, it may be with respect to dependent variable or with respect to independent variables. So, if it is independent with respect to independent variable, it is called as a dummy independent problems. If it is related to dependent variables, then it is called as a dummy dependent problem. So, the techniques are more or less same. So, it is in fact interesting. So, we have discussed with the general format, then with respect to linear probability model or binary choice models, logit models, then finally probit models. Okay. So, after that we have discussed the penal data models. Penal data models. So, because we know we have discussed till now, we have discussed the entire cross sectional modeling, then we have discussed the like time series modeling, then penal data setting like this yi equal to alpha plus beta xi plus u, then yt equal to alpha plus beta xt plus u ui, then this is ut, then yit equal to alpha plus beta xit plus UIT. So, these are the three forms of the models which we have discussed in the entire econometric modeling. So, few problems are purely cross sectional type, few problems are purely time series type, and few problems are joint. Okay. So, that is what is we call it a penal data modeling. It may be in the with respect to pool data or with respect to pure penal data settings. So, in the case of penal data setting, so we have discussed two models, two interesting models called as a fixed effect model, fixed effect model, and a random effect model. Fixed effect model with respect to time component and cross sectional component, and random effect model specifically which integrates the error variance. Okay. So, this we have discussed in the penal data, it is very interesting. Then we have discussed the simultaneous equation modeling, simultaneous equation modeling through where we have discussed the identification problem, that to whether the model is means it is a simultaneous equation modeling means variables are interdependent in nature. So, before simultaneous equation model, so we have the system one way system. So, that is one dependent variable with several independent variables, but most of the cases you will find variables are very interdependent in nature. So, there is a once they are interdependent, then obviously the system will be, there will be a system, and that system is called as a simultaneous equations modeling. So, with this particular structure, so what we have discussed, the a model has to be first identified, that to exact identification, over identifications, and you can say under identification which cannot be identified properly. So, then under once it is identified, model is identified, then obviously we go for estimation. Generally in the simultaneous equation modeling, OLS is a least application. So, we have different techniques altogether for simultaneous equation systems, like reduced form of the models, then indirect least square method, two stage least square method, three stage least square method, full information maximum likelihood methods. So, many methods are there, method of instrumental variables. So, these are the methods through which we can solve the simultaneous equation problems. So, then we have discussed the structural equation modeling, where it is just part of the simultaneous equation modeling, but here in the structural equation modeling there should be proper structures. So, and in fact, in that structure there is always two-way causality. So, it is the structure of we every time we like to know what is the existence of covariance and correlation among the various items, how they are interrelated to each other, and in fact very interesting. So, because most of the problems in the real life situations are very interdependent and very structured. So, structural equation modeling is very helpful to solve this type of problems. Okay. Then we have moved to time series modeling. So, time series modeling. So, we have discussed various aspects of time series modeling, starting with the basics. What is the setup of time series framework? Then we have discussed various models like autoregressive model, distributive lag models, then ARIMA models, autoregressive distributive lag model joint. Means in the case of autoregressive models, it is the endogenous variable as a function of a lag of endogenous variables. Then in the case of distributive lag models, it is endogenous variable as a function of exogenous variable and lag of exogenous variable. So, we can also join, and we have also discussed how the distributive lag model can be transferred into autoregressive model, because most of the schemes in the time series setting is in the autoregressive way. So, there is you can properly directly handle through distributive lag model. So, we can directly also handle autoregressive model, but there is a way how you have to transfer the distributive lag model to autoregressive model, that is which we have discussed in the quick methods. Then we have discussed volatility modeling. So, in the case of volatility modeling, so what we have discussed? We have discussed autoregressive schemes, then moving average schemes, then ARIMA models like the means basically what we have done means our structures altogether. It is a cross sectional modeling structures, then time series modeling structures, and penal data modeling structure, and structural equation modeling structure. These are the various structures we have discussed in enter our enter this class, whatever we have discussed during the entire periods. So, this is some of the problems are pure cross sectional time, some of the problems are pure time series types, some of the problems are penal data setup, and finally, then there is a structural equation modeling. So, now I have already mentioned the structure about cross sectional modeling. I have discussed also penal data setting and structural equation modeling, that to simultaneous structures. Then time series modeling, basically we have discussed various schemes like autoregressive models, moving average models, then ARIMA models, autoregressive integrated moving average models, and before that we have discussed autoregressive lag models. In fact, autoregressive itself is a lag model. Then distributive lag models, then distributive there are many forms of the distributive lag models like polynomial distributive lag models, then infinite distributive lag models, then lag means autoregressive distributive lag models. There are many ways you can discuss these issues of time series modeling. So, then we have discussed again the volatility modeling, like from these autoregressive schemes we have arch models, we have gauge models, and we have E gauge, T gauge, etc. But we specifically highlighted the issues of arch model, autoregressive conditional heteroscedasticity model, and generalized autoregressive conditional heteroscedasticity model. The heteroscedasticity problem we have discussed in the case of cross sectional modeling, but now we are using this this particular problem in the time series setting. Generally, before time series modeling, our standard assumption is that, or standard thinking is that autocorrelation is a time series problem, heteroscedasticity is cross sectional problems. But in real life situation, or you can say in effect, it is fact in fact, it is a fact that correlations, autocorrelation heteroscedasticity can be observed in the case of cross sectional modeling, can be observed in the time series modeling. Okay. So, this is with regards to volatility modeling. Then we have discussed various means specific problems of our time series modeling, that to unity root unit root problem, co-integration problem, causality problems, then vector error correction model. So, unity root test, there are several tests in fact, but we have discussed decupolar test, augmented decupolar test, then finally we have discussed means then co-integration, that is the existence of long run equilibrium relationship between two or more variables. In fact, that is the second part of the time series modeling. Before that, unit root means stationarity of the variables you must properly check. Then if there is something means if the variables are integrated of order 1, 0 or 2 like this, then obviously the modeling setup will change accordingly. So, generally we start with the stationarity issue of the time series variable, that is unit root problem. Then we have to move to the co-integration problems, where we can discuss the existence of long run relationship. Then finally, we have to discuss the causality problem, because if you causality means if you have two variables x and y, say, then x causes y or y causes x. Before that, we have a one directional causality, that is one way causality, but time series has a specific importance, that there is a both way of causality can be derived. So, in case of there are two variables, then either they have no causality, or there is unidirectional causality, that means x causes y, y does not cause x, or vice versa, y causes x, x does not cause y, and there may be possibility x causes y and y causes x. And if that is the case, that is called as a bidirectional causality, and if only case of one x causes y, y does not, and vice versa, then it is called as unidirectional causality. And if x does not cause y and y does not cause x, then obviously it is called as means there is no causality. So, this is what we have discussed, and in the same times we have discussed the vector error correction models, because in the co-integration, in fact co-integration we have discussed through easy procedures and Johansson procedures, that is purely in the matrix eigenvalue and trust statistic issue. So, in the Engel-Granger methods, so we have discussed the linear relationship between two variable time series variable. Then that error terms we have observed that stationarity in natures. So, after having all these things, then when we will come to vector error correction models, then obviously from the co-integration equations, where we have studied the linear existence between two or more variables, then that error correction may be have a significant impact on a particular variable at the current time period. So, that is why we have observed through vector error correction models like this. You can say summation y t equal to summation alpha I x t minus I plus you can say plus summation beta I y t minus j, okay, plus error correction E c t minus 1, okay, error correction term t minus 1. Of course, there is a b t. Okay. So, similarly x t can be written as a summation alpha I x t, this is y. So, it should be y t minus j, it should be x y t minus I, this should be x t minus j. So, similarly, in this case x t alpha I x t minus I plus summation beta j and then y t minus j plus error correction terms t minus 1 plus b t. So, this error correction term, when we will integrate y as a function of y t as a function of x t, that is a co-integration equation. In that case, x t as a function of y t, and that is co-integrated equation. So, we like to see whether this has impact and this has impact. This is called as a long run impact, these are called as a short run impact. This is to be investigated through F statistics. Okay. So, that we have already discussed in our last lectures. So, now with this particular specifications, so then we means these are the complete structures which we have discussed within this particular semesters. So, what we have to means what I have to do right now. So, I will just giving you a brief framework or modeling strategy. So, what is your core idea, or how you have to come to a specific or structures through which you can we can enter a particular problem very straightforward, and you can also get the answer very accurately, and you can also apply this particular model in a very authentic way. So, that is how it is very important to learn some strategic issue and strategic facts. Okay. So, here the model precisely highlight we can say various strategic rules are there. It is not that you have to learn only techniques and only to learn problems. In fact, problems is always there. So, objective you can derive, hypothesis you can set. There are several methods are there you can get to apply, but which particular method you have to apply and how you have to apply and how you have to interpret, that is very interesting, and that is more and more complex game. So, it is very important to know strategic issue, how you have to enter to that particular problem, then how you have to get out the solution. It's not like that you are just entering to the problem and it's very difficult to come to a particular conclusion. So, that's why if you know proper structure and proper setup, then obviously you will quickly enter to that particular problem and you can get quickly answers, and that answer will be very perfect and can be used for some policy use. Okay. Otherwise, you just it is if you haphazardly if you are just going to estimate something, or you can say doing something, and that is not the econometric modeling. Econometric modeling, you have to apply your strategic idea, how you have to bring the analysis in a strategic way. That is very more important. Okay. So, I will briefly highlight a few important points. So, that will be you can consider these are all strategic rules for econometric modeling. So, first thing is model selections. Okay. So, model selections. First is model selection. You see, we have altogether different setup of models: cross sectional modeling, time series modeling, panel data modeling, structural equation modeling. So, every times means most of the cases when you are in the huge problem area and deeper in the side, then obviously the problem will be more or less multivariate in nature. So, once you are and generally you assume that you are in a multivariate problem, because bivariate is not the utility of bivariate model is very less, while the utility of multivariate model is very high, provided all the parameters should be significant and overall fitness of the model will be very significant. Then by default that multivariate model will be better choice. So, now when we will go for a multivariate modeling, so you must be very careful. So, whether it is in the cross sectional setup or you can say time series setup. So, you have to learn few things, and you have to clarify yourself few things. First thing is model selection. For instance, you take a case of cross sectional modeling. So, if it is a multivariate models, let us we start with you can say 20 variables or 30 variables. So, there may be issues that 20 variables may not be relevant, and in fact, you are using unnecessary variables and necessary variables you are excluding. So, that is how. So, model selection criteria is very important. Okay. So, it will give you whether your specification with respect to inclusion or exclusion of variable are okay or not. This is one way, and in the same case to put it in the case of time series modeling. So, we start with a single variable called as univariate modeling, univariate time series modeling, then multivariate time series modeling in whatever situation. So, we will create several variables, independent variables with respect to its year lag. For instance, like yt minus 1, yt minus 2, like this way. So, in the time series modeling, it is its beautiness. So, you can create a number of variables further, but if you create a number of variables, your degrees of freedom will be get reduced. So, you must be very careful. So, that is why how much lag length you have to consider, that is very important. That means, in the cross sectional modeling, how many variables you have to introduce, here how many lag variables you have to introduce, that is in the case of time series modeling. So, in all the cases there is a trick how you have to choose this optimum size of the model. So, there are several statistics, say AIC statistics, SIC statistics, HQC statistics, final prediction error statistics, even if R square, adjusted R square, root mean square errors. These are mean percentage errors, absolute mean percentage errors. Okay. These are all you can say these are the methods through which you can we can observe the model selections. So, whether model is perfectly okay or not. Okay. This is first problem, means first strategic idea behind this modeling, econometric modeling. Second is the model must be consistent with the theory. Okay. So, model must be consistent with the theory, because theory will help you in the modeling in two ways. First, it will give you introduction, means it will give you setup for objective specification and hypothesis specification, and also it will give you at the end of the modeling. So, that is when you will go for interpretation after getting the reliability of the model. If the reliability model is okay, then obviously you have to go for interpretation. So, that interpretation basically it has a strong connection with the theory. What is the theory? On the basis of theory you have to interpret the entire models. So, that is why theory must you must learn or you must know theory very well before you go for any type of econometric modeling. Econometric modeling is just not a statistic or mathematics, because it is purely application oriented subjects. Okay. So, you need to apply math and start just to verify that theory or you should justify that theory. That is the main or core agenda of econometric modeling. Okay. So, theory is the must. Okay. So, then explanatory variables should be uncorrelated. Okay. So, that means independent variables should be totally independent, whether it is a time series modeling, whether it is cross sectional modeling. You know, whatever variables in your system in the right side of the modeling, that is, you know, in the form of exogenous variables or independent variables, these should be completely independent. If you are having a good multivariate models and all these you know independent variables are not correlated, then obviously that model is perfectly very fine and perfectly okay, whether it is time series setup or cross sectional setup. Generally when you will enter more and more variables, then there may be some interdependence among them. So, you have to check whether there is any interdependence. If there is no such interdependence, then obviously it is you are absolutely okay. If it is there, then that leads to, you can say, multi-correlated. Basically, in this particular setup, you have to face always three different problems. First is a multi-correlated problem, autocorrelation problem, and heteroscedasticity problem. So, these three problems are always there. So, that is why you must be very careful. So, model must be means this independent variable should be, you can say, totally independent so far as a best fitness of the model is concerned. If you are getting to that situation, then it is okay. Otherwise, you have to find out the possibility what range you have to consider where your model fitness will not be affected. So, that is how it is independent variables, that is explanatory variables should be uncorrelated. Then for random variables, residuals, that is residuals should be purely random in nature. You remember in our model we have three different structures altogether. First structure is, you can say, first structure is dependent classification, independent classification, and error classification. Okay. But when we set a dependent variables, whether it is a structural equation modeling or simple cross sectional modeling, time series modeling, it is not a issue. In the case of structural modeling, instead of one equation, you may have a multiple equation. Okay. Similarly, in the case of simultaneous equation, but every cases what you have to see, there is one equation at least. If you consider one equation, there is definitely there is a dependent structure, independent structure, and error structures. But error is just to capture the which we have not represented in the form of independent variable. For instance, like this, y equal to function of x and u. So, if u is not there, then obviously the y is 100%, x is influencing y 100%, but it is it is not possible every time. So, as a result, So, if it is 90, then obviously 10 will go to the error, if it is 80, 20 will go to the error. So, that means there is some variable which you cannot immediately capture. So, that variable should be considered in the form of residuals, but you know, so that should be purely random in nature. So, if you know that this variable can be measured, can be quantified, then you should immediately take into the model. So, independent structures, if not, it is not, just like you, the component say lock. So, lock cannot be possible. So, it is coming in the error term. So, sometimes lock can be also you can say can be investigated in a quantitative way by using the dummy variable technique, but that is a very rare concept. Some of the other item also say, you know, earthquakes, etc. So, in that case it is very difficult to predict all these things. So, it has to be altogether coming under error terms. Okay. So, residuals must be you know, random in nature. Okay. Then finally selected model must be efficient and significantly better than other models. Okay. A model must be efficient. So, you see, once you go for modeling strategy, which I have highlighted a long back, that there are various procedural measures. If it is a reliable one, then you have to go for analysis and, you know, hypothesis testing, then policy prediction, policy use, etc. If it is no, then again you have to go back to the, you know, original situation where you started with mathematical form of the model, then statistical form of the model. But you know, once you say that this model is best, then obviously it should be very efficient than the others, and no other model can be overtake this particular model. So, then that model can be used as a for forecasting or prediction, or can be used for policy purpose. Okay. So, this is how model must be efficient, and obviously it will be significantly or substantially better than the other models. However, if all these conditions are not specified, suppose whatever strategy I have given to you, these are not okay with you, then obviously what are the problems you have to face? Then obviously this is called as a model misspecification. This is called as a model misspecification. So, what is model misspecification? That means means what are the ways you have to misspecify the model. There are certain cases. One case is including, you know, unnecessary variables in the systems. Then second case is excluding relevant variables in the system. So, the inclusion of unnecessary variables. Okay, unnecessary variables. Second is exclusion of necessary variables. Exclusion of necessary variables. Unnecessary variable, necessary variables. Okay. So, then wrong functional form. Wrong functional form. Then last but not the least, wrong specification of the random term, wrong specification of the random term. Then finally, a wrong choice of methodology, wrong choice of methodology, wrong choice of methodology. Okay, a methodology, no model specifications, like, you know, criteria, wrong choice of criteria, wrong choice of criteria. Okay, so these are the things where model will be misspecified. That means, if you are not statistically strong in econometric modeling, then obviously the model by default will be misspecified. So, how do you know that this is misspecified? Okay. So, obviously, so you have to go for consequences. Okay. The consequence, if the model is misspecified, then obviously the model cannot be what we call is a blue theorem, best linear unbiased estimators. The model cannot be, you know, follow the blue theorem, and it cannot be used for forecasting, whether it is, you know, cross sectional modeling, or whether it is a time series modeling, or whether it is a panel data modeling, or whether it is a simultaneous equation modeling. Okay. So, in all the cases it will affect the blue theorem. Okay. So, now this is all about the modeling strategies. That means, I have mentioned what are the strategic point we have to consider before you go for saying that this model is best fitted. And because the beginning of the models, you are what is the beginning of this structure? You have to fit the data into that particular problem. So, that fitting in data into that particular problem means it is to get a beautiful models. So, that model should be considered as a best fitted model. So, now it is not easy, or it is not straightforward to get the best fitted model. So, you know how you have to enter to that particular problem, how to get the best fitted models. So, you start with the specific idea, then ultimately you have to solve that particular problem. So, in that case, if it is not straightforward, why? Because there are certain strategic rules you have to follow, which I have already highlighted. Okay, so these are the points you have to take care very carefully. Then I am very sure at the end of the day you will get the models best fitted, and that can be used for forecasting. Okay, in any case, if you are not sure whether you are still if all these criteria is fulfilled in favor of you, then the model will be correctly specified, otherwise it is misspecified. Still, even if you get correctly specified, then there is a advanced test called as a reset. Okay, so there is a last stage of this modeling is called as a reset. This is called as a Ramsey regression specification error test. Okay, specification error test. Okay, so what is this test? So it has a altogether 4 steps. Okay, so first step is we start with a models. So y equal to function of x1 and x2. Then what is the starting means how you have to enter with that particular model. Then obviously you have to transfer into the statistical form of the models. Statistical form of the models. Okay, statistical form of the model. Then this is so ultimately you need to have a y head. Okay, y head equal to alpha head plus beta head, beta 1 head x1 plus beta 2 head x2. Okay, so this is estimated models, and we have gone through all these reliability measures, and all these you have passed all these things, and finally it is correctly specified. Still it is doubtful case. So what you have to do? So you have to check whether it is correctly specified or not, means for advanced checking. So you get it here R square. Then again you estimate the models. You have the estimated models by incorporating like this alpha head plus beta 1 head x1 plus beta 2 head x2 plus gamma 1 y head squares. Okay, plus gamma 1 heads, then gamma 2 head y2 y head to the power 3, then gamma 3 y head gamma 3 head, then y head to the power 4 plus. Okay, error term will be automatically removed. Then again you fit this model, and the estimated model will be like that way. That means once you estimate the model, the estimated variable will be again added into that particular problem. Then you have to re-estimate, and finally you get all these estimated result, and finally you get the R square value. Then you construct a F statistics. F statistic R square new, okay, minus R square old, okay, then divide by number of new regressors. These are all new regressors. Okay, number of new regressors divide by 1 minus R square new into divided by n minus k. If this F statistic is significant, then model is misspecified. If it is not significant, then its model is correctly specified. Means this is the last option of model checking. So if it is essential, then you have to go through it. Otherwise, if the model is correctly specified by all these reliability testing, like goodness fit test, specification test, and out of sample prediction test, that is nothing but the all details about DG test, and obviously the model can be considered as the best fitted model. Then finally, what is my conclusion is that out of before starting a to econometric modeling, you must know theory very well. Then you design the objectives very carefully, design the hypothesis very carefully, design a mathematical form of the models perfectly. Then finally transfer this mathematical model to statistical form of the models. The moment you will set the statistical form of the model, that is it's beginning of your analysis part. That is more complex, more interesting, more strategic, etc., etc. So you have to apply very strategic way. Then finally you will get the estimated model. Then ultimately you have to go through reliability checking, then reliability checking, goodness fit test, specification test, and out of sample prediction test. Then finally you have to also end of the day you will go for Ramsey reset, Ramsey regression specification error test. Okay. So now if all these things are correctly specified, then obviously that model can be used for prediction and forecasting, and also obviously it can be used for policy use. If not, then you have to continuously rotate till you get the best fitted models. Okay. So, that is why if theory, the fundamental concept is if theory is perfectly okay and you have genuine theory, then obviously I am very sure econometric modeling will definitely help you to do something for future, or you can say forecasting. If the theory is not okay, then obviously data will not the fitting of the data may not be helpful to go for prediction and forecasting. So, you must be very thorough about the theory, all these techniques and all the strategy, how you have to fit the data into that particular problem, and how you have to get out with the best fitted model, and finally how you have to use that best fitted model for forecasting and you can say policy use. With this, we will end these chapters. Thank you very much. Have a nice day. Bye bye.